All right, welcome back to another coding session. I'm recording this straight after the last one. Just grabbed another cup of tea to recharge the batteries and get stuck back into it. Back into types. So last time we added these annotations for parameters, return types. We also added comments, and one thing I wanted to do in our Bangalang file type is we can say what our language uses for comments, single line and block comments. And you can see the way that it's handling it, because this is just kind of some generic support that JetBrains gives. It's assuming that nested multi-line comments is not supported. See, it's ending the comment here. Just as soon as it sees this pattern, it ends. So it's not going to highlight our multi-line comments very well, because that looks like it's outside the comment, but actually it's valid. But our single line comments should look fine. It would be nice if I could spell too. But now we're going to get stuck into actually enforcing these types. And when we go up to the top here, you can see things like here, we're declaring the variable z to be number 10, but it doesn't have a concrete type. So I'm just going to put myself on do not disturb. Should have done that earlier. Yeah, it's not going to know the type. So this I would expect to throw an error, because we need to explicitly say, like we did up here, what type the number should take. Because here, the way I'm treating this is just a number. You know, we don't know what kind of number it is until we assign it to something that does have a type. So this also has no type information. So let's enforce type checking. I think that should be nice. Bit of a challenge, but I think we can handle it. I'm going to be spending most of our time in this type checking file here. So I think we're going to start from the bottom. Going to go bottom up. We don't have any, there's no new tokens, no new parsing. It's just checking that we're doing today. I don't think we're going to touch generation either. So even though we have a 32-bit and a 64-bit integer, we're actually going to generate assembly for 64-bit for everything. I think that might be the next episode, is where we actually get the generation working properly. But let's look, okay, so let's start with a call. When we are calling a procedure, what type checks do we need to do? Well, we need to type check all these expressions are the parameters, right? So we need to make sure that they match what is expected. And what is expected is this, right? So we need to grab that for the correct index. We need to do it before we increment this. So maybe we'll do it like right at the start. And we'll say param data type is that, I think we have to do child index -1, right? Yeah, because the first child is the name of the procedure we're calling. So index -1 should give us the parameter index. So that's the expected data type. And then this expression. So the way I think I'm going to do it, I think a lot of the magic is going to happen in this expression area, actually. In here, we're going to, or even if we go down to primary, these are like the smallest building blocks, right? Like here is a variable. We found a variable. So this node should take on the type of the variable. And then we're going to percolate the types up through the tree. So if we go back to the AST over here, so we start down here. This is like a primary, right? This could be an identifier or an integer literal, and then we're going to percolate up. So if we find that this is an I32, and this here is, say it's just an integer literal, so it just has type, we'll call it type number, just like an ambiguous number type. Then we compare these and we say, okay, the type that we really want is I32. So then we set both of them to be I32, and we also set the parent to be I32, because that's going to be useful information, I think, when we do, well, if it's a complex expression, then when we go higher up and we want to compare the left-hand side or right-hand side, then it's just handy to have the type information right here. So we're going to percolate up the expression. And my goal is that once we've finished type checking, every node that needs to have a data type should have a concrete, like a proper data type, you know? Like I mentioned that an integer literal would just start with the data type number. I mean, here's an integer literal, so let's just do that now. So it starts with number, but by the end, we want to make sure this has a proper data type. Yeah. So I might even change this integer literal to number. Is there anywhere I have that like lowercase? Here we go. Found invalid token, found character blah in number, so that's tokenization. Why does that still say tokens.odin? And integer literal, oh, so this is our grammar. So yeah, for our grammar, we'll just call it a number also. But if we open that, tokens.odin? Oh, that's barely a lang. That's a different language. I thought that I found that error message a little bit like I didn't recognize it. That's because it's from a previous project. Okay. And why is that not allowed? Because we need to pass node by pointer. I guess we're going to need to do that everywhere. So wherever we pass a node, we need to pass a pointer to the node. So that makes that happy, but that means that we need to do address of, and probably in quite a few places. Address of the node, which is not allowed. I think we came across this earlier. You need to do this. Don't ask me what's going on there. But if you put enough ampersands, it works. All right, where's the next one? Scope node. I think in this case, we'll just make our variable a pointer. So then if we need to like modify anywhere in this scope, yeah, I mean, if we did this, we could do this, but then if we need to modify this variable anywhere in this procedure, then this is effectively a copy, and it's, no, that's overall not going to work. We have to do it like this, because otherwise we've taken a copy of the child, we're passing that in. Any changes we make to it are not going to be in the AST tree. I try not to do that. AST tree, that's a double up of the T. Anyway, we're going to put our ampersands here because it's better. In this case, we don't have a variable for them, so we put it directly there. Declaration node, the expression. This one here. There's one here. This is a loop, so I guess we need to do this business. OHS node, so let's do both of those like that. And both of these. That one. Both of these. And then down in here, there's the parameter node. Okay, everything is passed by pointer. So this is where we were. So we're saying that this starts off as a number. Just a number. We need to figure out what it is though. If we're going to use it in some sort of operation, we need to know. Eventually we need to know what it is. In this case, so if we have an identifier, it doesn't mean that we know what the identifier type is. Actually, if we have it in an expression, it must mean that it's been declared, as we say here, and the data type is going to be this variable type, right? Which reminds me that we actually need to set those, don't we? We were just setting them to empty string. Here we're type checking a procedure. The param node of a procedure does have a data type. We made sure of that in the last episode. Okay, here we're doing a check. Okay, and we're setting that, this is the declaration. So this is going to be a bit more complicated to find out. I mean, the LHS node might have a type if we do this. So I guess at least to have something, we can start with that. But it might not have a type. You know, it might infer, like here, Y does not need to specify its type because it can infer it from X. So we need to add that later. But right now, I think we just want to make sure that this type variables is being filled out. Okay, and it looks like it is. So in our primary, yeah, we take on the data type of the variable. That makes perfect sense. And then, so then in our expression, after we've type checked our expressions, we need to make sure that we have a valid type for everything. So I think probably what we're going to need to do is have like an expected type actually. Because in some situations, the expression itself is not going to know, like if we go back to this first line, this is an expression, right? And nowhere in that expression does it say any type information, but we're expecting an I64. So if there's no, if the only type of information we have in here is number, then we can upgrade it to I64. All right. Yeah. And the way we do that is we pass in an expected type. So I think that needs to go into the primary as well. And so that needs to pass it along. So here, do we just set it to the expected type? I don't think so. I think we just leave it as number for now at this point in time. Yeah, I guess we just pass the expected type in here because we need to pass it on to any nested expression. and possibly to this, but we don't know. I don't know yet. And then, so then after we've done this, we should have appended type information to the left-hand side and right-hand side node, right? Through this kind of thing. So then what we want to do is check, like, are they compatible? What's the final type of this expression? And that's, I believe, called coercion. So we're going to add coerced types. What coerced type? I'm not really sure, because we're passing in one type and we're getting back one type. No, we're passing in two types and we're getting back one type, which is sort of like the final type, you know. And, or the coerced type. Let's call that type A and type B. And the coerced type is an empty string to start with. And then we can say if type A equals number, type B equals, well, I guess basically we can say if type A is the same as type B, then we return one of them, right? They're the same. Oh, we need to return a string. And if they are different, then, well, I guess if type A, because there's the case that they could, I'm thinking just in real general terms, like what if either of them doesn't have any type? Then I guess we want to probably return maybe a flag to say whether the coercion was okay or not. Sorry, not, we need to return actual value, true. So here we say false. And we just go back the empty one. Okay. And we know it can either be number or I32 or I64, right? So if either of them is number, we know they're not both number, but if either of them is number, we take the other one. So I guess we could actually say, you know, if type A is number, then we take type B. And if type B is number, we take type A. And in this case, and we've established that they're not empty string, and a little bit indirectly we've also established. So here we've said type B is not an empty string, it's not number, and then the only other option is that it's like a proper type, a good type. So we say true, we say true. Now, if we haven't been into any of these, what it means is they are not equal, they're not empty string, they're not number, so they're both proper types, but they're different proper types, which is also not allowed. They have to be the same. We're not going to have any implicit type conversion, not yet, because it's extra complexity. We're just going to say the types have to be exactly the same, or they can be upgraded from number. That's it. So this is our coerced type procedure, and this is what when we're doing our expression, we type check both of our expressions, and then we say coerce type, and we give both the types. These should have types on them now. Oh, RHS node.datatype. And I'll just call that type and coerce OK. And of course, if not coerce, no, not coerce OK, then we flag the whole expression is not OK. And now, so this node takes on that type. So the type of the expression, in this case, it would be, you know, like an add, subtract, multiply, or divide. That node will take on the resulting type here. Oh, this is data type. Maybe I should call that data type also. Yeah, maybe everywhere I should say data type just to, I should have done a copy and replace or something here. Oh well, almost done. Just for, don't think we actually used that. Bit of extra clarity. Okay. Yeah, so because this coerce type is kind of like our final type for the expression. So we set it to those. And I guess we can also set both the left and right hand side to take on that type. Right? Is that a safe thing to do? I think it's a safe thing to do at the moment. I think in the future it might not be. But at the moment, let's just throw that type everywhere. Okay. So that makes sure that this node has a proper data type if it's an add, divide order, and also its children have proper data types. Now, what if its children are also adds and multipliers and stuff? Yeah, at the moment, because we don't have any type conversion, whether it's explicit or implicit, we can just say make everything this type. I really do think this is going to have to change later, but let's keep it simple for now. But up here, so the edge case that I'm thinking of is what if we have, you know, for example, this is our expression. It's just one node, it's just a number. So we go in and we do our primary, and our primary resolves the type of this node to just number. But when we leave this expression, so and then it'll return, and then we go back. Yeah, so we will leave the expression with this node still just having number as its type, when really it should take on the expected type. But I don't want to do the coercion and stuff in here, because that coercion could fail and mess things up. And you know, I want, even if these coercions don't result in a proper type, the coercions within these calls, that's totally fine because we fixed it up here. So all that to say, I want to have somewhere where in the case where we just have a single node in the expression, it also gets tidied up. So I'm going to do just an _1 here. And whenever we recurse, we need to do 1. Should this one also be 1? Is that kind of recursing? Yeah, I think that's recursing, so we'll make that 1. And then the idea is just that when we come out here, if we still have a number data type, which should only happen if we just have one node, then we try and coerce. We try and coerce it into something nicer. And if we fail, then it should be an error because we are expecting, yeah, like I said, after type checking, everything should have a solid type. We should not see number anymore. So I might just, because we're not generating yet, what I might do is we might just do like a bit of a loop as a test where we just traverse, or maybe not a loop, but a tree traversal where we traverse the whole tree and just double check that nothing has number. Everything has a proper type. Okay. So we're coercing between well, I guess the node data type and the expected type. And then we set the node data type to be the result. Like so. Okay. I think that's going to be enough to propagate these data types and make sure that all of our expression nodes, all of our arithmetic nodes and our primary nodes have proper types. So now we need to look at everywhere where we'll do the call a bit later actually, because the call's a bit complex. We need to look at everywhere where we are doing an expression, and then we need to put in an expected type if it's relevant. So when we're type checking an if, the expressions for an if, ideally they should return a Boolean, but because we don't have Boolean data types, I'm going to nominate I64 as the type that if statements should have. And I guess probably the for loop also has expressions that should be Booleans, but I'm going to say I64. And then when we do a declaration, this is where I said we would need to do a little bit more, because we might end up taking the right-hand side node data type and using it for our left-hand side if we don't have type information for the left-hand side. So what would our expected type be? I guess it would be this, right? Now in some cases that's going to be an empty string. Did we allow, like one of them can be empty, right? No, none of them can be empty. Neither of them can be empty, but I feel like for this case, like for a declaration, this might be empty, and I think that's okay. But for something like an expression, that's not okay. But in an expression, it's never going to be empty. The primary is always going to have something. So I think empty string, I've gone to the wrong place. I think in here, an empty string is only going to happen, it's not going to happen in an expression. It could happen in like declaration or assignment or something like that. Let's see where else it happens. Where else are we, luckily because we have to add a parameter, we can see all the places. So in assignment, well, no, in assignment we do this, right? we know the data type. That should be a concrete data type. And if it's not, well, it'll still fail, right? Maybe we can, where are we coercing? In here, maybe we can make one of these the expected and one of them the actual. In this case, right-hand side would be the actual and left-hand side would be the expected. Well, no, I guess, you know, this is a binary, so there's no such thing for a binary operator. There's no such thing as actual and expected. I guess we could say, well, let's, we could say this is like the LHS data type. And this is the, hey, didn't I? Oh, God damn it. LHS data type, enter, enter. RHS data type. Okay. Let me just check where we've called that already. So there's here, LHS, RHS, and here. Here, I guess the expected type would be the LHS. So I think the LHS can be empty. Now that we put it like that, LHS can have no type as long as the RHS has a type. And the expected type, when we're in expression here, the expected type, where is expected type actually used? We're not even using it. Do we need a third? Maybe we need to have 3 in here when we're checking types. Left-hand side, right-hand side, expected, and at least one of them needs to be good. And they can't conflict with each other. And can we just, I mean, I feel like I'm trying to maybe be too clever. Can we just say if some of them are empty, as long as one of them is good, then everything takes on that type? Okay. Sorry, I'm getting a little bit lost, I feel like, here, but let's just take in a slice of data types. And let's say for data type and data types, and coerced data type. So if the data type is empty, or the data type is number, maybe we just say we can't use this, so continue until you find a good one. And if coerced data type is not empty, so we've already found a proper type, and this data type that we're looking at now is not the same as it, then we're going to have to return false, right? Then we've got a problem. We've got conflicting data types, essentially. Otherwise, we say coerced data type equals data type. Okay. Let's just say that. If we get through that whole loop and coerced data type is still empty, it means we didn't find a proper type. So that's false. Otherwise, we return the coerced data type with true. Somehow I feel like it's nicer to do this the other way around. So then it's kind of like you have to prove that you're true, and the default is that you're not. So you have to prove that this is a valid coercion of types. Okay, let's try that. Hopefully that's going to work. So now when we coerce here, we can supply an arbitrary list of things. We'll put the expected type in there as well. So as long as they're compatible, we take the resulting type. And here, we take the resulting type. And now we can go back to our assignment, which is down a bit, or our declaration. We're expecting the left-hand side. It could be empty, right? But hopefully between the left-hand side and the right-hand side, we can find a valid type. If it's not okay, then we flag as such. And if the left-hand side didn't have a type, we take on the type of the right-hand side. Yeah, so that becomes the data type of the right-hand side. I think that makes sense. We try to figure out the type of the right-hand side, and we give it the left-hand side. In case there's no type information on the right-hand side, we can use the left-hand side. And then when we get back from that, in the case that the left-hand side didn't have type information, we take it from the right-hand side. So either side can take their type information from the other side, I think is the summary. And then we set the variable to be whatever the left-hand side is resolved to. When we do assignment, I feel like it's a bit easier because we already know what the left-hand side is. We just try to get the right-hand side. So I don't think we don't need this kind of stuff. For return, the expected is whatever the procedure is expecting to return. But we don't know that in this context. And I think the way to find out is that we're going to need to add some context. I think we need to add it to the context object here. The current procedure that we're in. So when do we enter a procedure? It's when it's at this point. Yeah, we create a scope context, and that scope context will need to take on the procedure. So I guess it's going to be like in the call, right? Where is our call? We have this loop. It's going to be a similar loop up here. But in this case, so scope context.procedures. In this case, we're going to say scope context.procedure becomes the result. Oops, got rid of the S. There. So now I think we know our current procedure that we're in. So we should be able to go context.procedure.return data type. That's what we're expecting. Okay, and what's the issue here? So this is the call. So down here, That's right, we're going through the parameters and checking that everything's okay. So yeah, we don't need to deal with the return here because that's what we dealt with just now. The other place we only need to deal with the parameters, the types of the parameters here when we do the call. So we need to make sure the expression is compatible with the parameters data type. And I think that's it. I think that's it. If we run that, you know, I was not expecting that to work. As in, it should not have worked because, yeah, like I said, this here does not have type information. It should have failed. So at the moment, we're only coercing types when we're in the expressions. And whenever coerce okay is false, do this. So maybe this is too lenient. Quest data type is not 0, not empty. So I don't think we have any cases where this would happen, but we should have cases where, yeah, where we should end up here. And then we should at least get a return type of 1. We're not printing out any errors. We're not printing out any errors. So maybe we need to, do we do it here or do we do it within coerce type? I think we'd do it there. So failed to type check expression incompatible types. Maybe I'll just put the types there. So can I just do this? No. Slice of strings. And then can I put that there? Oh, probably because I put a literal, but I didn't say what the type was. If we do that, incompatible types, does it come up with any incompatible types? No. Interesting. And up here, oh, look, type check expression. Okay, I think I found an issue. Incompatible types, data types. So here we do the same thing. Oh, semicolon. I do that by habit sometimes, like that. And before we do that, let's actually call the main type checking procedure. Huh? What do you think about that? I think that could help. That could be why it's not finding any errors. Okay, failed to type check expression, incompatible types, number and nothing at line 7. Yeah, so here we go. That's totally correct. There is a number and a nothing. So it could be incompatible or incomplete. Is also, I think maybe we can improve the error messages. But at least we got something here. So line 7, 10, I mean, that's legit. So we can fix that. What's the next one? Line 12. We have a few errors at line 12, and they're all saying that there's combinations of number and nothing, which is also true. We don't give any type information here, so let's add some. Okay. I think that resolved a few other ones because we're using that result in a lot of places, and all those places there would not have been type information. So now we can go all the way down to 50. Again, this is legit. So far I'm happy, like all these errors are legit errors. I guess 51 also, yeah. 54, but that should be resolved now. 58 is probably, yeah. And 59, column 16. Yeah, which is here. So that's also legit. Make that an I64. Let's run that. Okay, we've only got a few errors now. So now we go to 66. We're at 66. Okay. So here, line 66, column 28. Is that this 4? No, it's the star. So that multiply does not know, yeah, it's got number, nothing, nothing. So this is number, obviously. It's got nothing from here. The expected is nothing. And it's also getting nothing from here. This should give something, or should it? Yeah, because add is a procedure and it has type information. So we should be able to add that. I guess that's a call, right? So if we go down to where we type check a call, this node is the call node. So I guess it should take on the procedure return data type. Then it should have type information, right? Yeah, nice. Okay. And this is legit. Nice. So I'm pretty sure that that is now all type checked. I'm pretty sure that's type checked. So let's do some checks to make sure that's legit. We could do something like if we try to pass this guy, or an I64, into here, where he's expecting a 32. See, that should be an error. PAL32 is expecting an I32, and we pass in an I64, and it's all gravy. Why is that? So that's when we're type checking a parameter. So that's here. Let's say param, okay. Well, I guess we never go in here, do we? But let's try to find the correct call. I guess it's the name node that we're looking for. So this is +1. We're actually looking for PAL32. It's the only call of PAL32. So when we find a PAL32, PAL32. Okay. So this should be the first parameter that we're looking at now, param node. is 3. Yep, this is the first one. It has a data type of nothing. Really, shouldn't it have a number data type? Well, I guess we haven't checked the expression of it. I mean, when we do this check expression, then we should get the data type back. So let's step over that. Let's put a breakpoint there. Okay, so now the data type is I32, yes. And yeah, because I guess it's taken it on from here. So param data type is I32. So it's copied it from there, basically. That makes sense. And then it should be okay, right? Yeah, it's okay. So step over. Then we come into the second one, which says param okay. I guess I should have stopped a bit earlier actually, but param data type I32. And the param node has a value of sum1, which is I64. Yeah, so that's I64. The other one's I32. So is our coercion not flagging things properly? And the other thing I've just realized is, within here we should get an error message if it's not right. So we should come to here, I would thought. If coerced data type has already been set, because we're coming in with an I32 and an I64, right? I actually want to just come back to this. So if we go, let's add +1, power 32, okay. Step over to. So here we are, we're at the second parameter, right? Param node has a value of sum1. It does not have a data type yet. Okay, it does not have a data type. Yeah, that's because when we do the expression type checking, that's when it takes on the data type. So that's when we would go into here. So if I try to step over, oh, what? What? We never coerce type? We type check expression. Only if it's number do we coerce the type. Maybe we should always check it against the expected type. Yeah, maybe we should just always do it. I mean, if it's been in here, it would have happened anyway. I guess we could do this. And then this is responsible for doing the parent. Yeah, so maybe we just need to do that. So it just always does it. Because in this case, this was not number, it was an empty string. Or no, it wasn't an empty string. It was, this was I64, this was I32. They didn't match, but they weren't getting checked. Okay, now we have some more failures. Okay. Yeah, so we have a couple like this. So what was the one? 76 was the one that we intentionally screwed up. So yep, that one is all good. Now we need to look at these. So 66 still has an issue. There is somewhere where it has, this is 24 now. So this is here. It's saying that there's 2 empty types to check from. And line 80, that one's interesting. So then it's like the parameter node does not have a type or something. This one should at least have number. I mean, come on. But it's a return. Maybe it's the fact that we're returning. There's 87. Oh, this one is not an issue. But yeah, maybe there's something in the return. And then 96. Yeah, so we said that for these expressions where it should be a Boolean, we've said it has to be an I64, but we're passing in an I32 here. Maybe we can just make that I64 because it's not actually part of the calculation, right? The calculation happens on this, and they are I32. It's just the exponent is I64. It's a bit janky, but it works for now. So it's just these 2 places that we have an issue. This is quite a complex example, isn't it? So let's, I think we'll put breakpoints where we have the type checking. We don't want to break just because we're coercing types or just because we're doing parameters. Okay. So it's the top level of the expression. What is a node? It's an add. That makes sense. Oh, it's this add. So it's this add. It's doing this add. So +1 should resolve to I64, and that should resolve to number. Right? Fail to type check expression, incompatible types. So the data type of the add is nothing at this point. And the children, it's kind of hard to look at. So we can see the call at least is an I64. Yeah, that makes sense. And the number I would have thought should be just number. Like, what else is it going to be? So maybe we need to, oh, that's going to break a lot. I'm just wondering how we can go back in time a little bit and debug what happened before this. I guess we can kind of rationalize that it would have gone in here and the call should take on, because when we type check the call, we added that line. Yeah, when we type check the call, it takes on the return data type. And the other side, the other side is this multiply. It's not the for, it's this whole thing. It's the multiply node. And the multiply node is not going to have a type, because I kind of thought that having this here would be enough, but actually that's only at the very top of the expression that it's going to do that, because all the nested things just recall this. This is our recursion one. This is only at the very top of the expression where it's actually setting the node data type. So we do need to do this here. And then it works. Hey, it works. So we at least have enough valid type information that in all the examples we've done here, it's happy that it can process, like, yeah, it's happy that in all the expressions, it has been able to determine what type we're talking about. So that's good. I'm pretty happy with that. Is there anything else we need to do? We could quickly do that loop or that traversal that I talked about. So we could say like is valid data type, and just say node AST node. And what that does is it says if node.datatype does not equal I32 and it does not equal I64, and we'll say can be empty, because some nodes in the tree, sorry, bull. Some nodes in the tree can have an empty one as well, right? And not can be empty. Or no, can be empty. Or I'm doing JavaScript here. Can be empty. Oh, this is racking my brain. How do I do this condition? So we allow this if this is true. Well, let's just do it in a separate condition because this is fucking crazy. So if it can't be empty, but we found an empty string, then let's just return false. You know, we found a boo-boo. If it can't be empty, but we found an empty string. And we recurse. I think we need to tidy up that condition because I think I've just failed miserably on this. And also when we need to handle this can be empty thing as well. I think they all can be empty except for like expressions. Can't be empty. Where else did we append data type information? I think it was just so that's the left-hand side and right-hand side. Yeah, I think this is not actually going to check everything properly, but it'll confirm a little bit just to make sure that we, well, I mean, is this even necessary? if we, I think that if we've got to the top of expression and we can coerce properly, and we've also coerced everywhere in between, what more is this check going to get us? This is, I don't know. I think this is not needed. And I think I'm happy. I think I'm happy. I think this is like all pretty well type checked. If there are any holds, it'll come up when we try to do generation, right? If we try to generate something and we discover that there's not enough type information to successfully generate it, then, well, then we have an issue, don't we? And we can solve it then. So I think that's enough for today. I'm pretty happy with that. Everything is type checked. We can't just throw any random thing into a procedure parameter. We can't just multiply two things together that have different types. I mean, I guess we can check that. We could say like, we could say blah equals y times z, because y is an I64, z is an I32. Yeah. So it's screaming at us. The error messages are not great. I will admit it. But they're there. The type checking is happening. Cool. All right, so yeah, that's enough for today. Thanks for stopping by. Next time, let's actually generate some 32-bit code. I think that's a good next step. All right. Ciao for now.